What a privilege to follow Amir. I don't know how he went the whole way through his talk without mentioning once that his foundation is backed by Elon Musk. I think it would be on the front page of every presentation I ever did if that was the case for me. I run a much smaller organization called Deep Science Ventures, and we create new science-based companies from scratch. And we do this outside of the academic environment, and we don't start with intellectual property sourced from universities. But before this, I used to do the opposite, and I used to start with intellectual property that was generated at universities and create companies that way around. And so the background to the talk is really a thesis about how we develop impact from scientific knowledge and what kind of talent is required for that. And so that's broadly what I'm going to talk about. And the main message is that I think we're only really accessing a tiny, tiny fraction of the value we could create from scientific knowledge, and that talent is really important. Okay, so if our ultimate aim is impact, I think we should start with that impact. So I'm going to pick off basically where Amir left us, which was, say you want to start with the end goal in mind. You want to solve the UN sustainability goals. How do you work backwards to develop inventions? And do we have the right infrastructure and institutions to do that? So knowledge first. So thinking about our knowledge institutions. Broadly, I think that commercialization efforts miss roughly 99% of the picture. And so here's how I worked that number out. A woman called Tara Alice wrote a report. She's now part of the McKinsey Institute for Government. That was sort of the landmark report that drove the UK government to adopt 2.4% as its target spend of GDP for R&D. And in that same report, she made a much less well-known remark, which was that 90% of the value created from technology comes from inventions from outside of the country in which that company exists. In other words, most of the work you're doing is already done. If you're commercializing a discovery, it's like 10%, and most of the value is coming from somewhere else. And yet, most tech transfer policies and most tech transfer focus and knowledge commercialization is focused on the discovery and the site of the discovery and the institution of the discovery, and not about how you combine it with the other 90% of the stuff that's going to generally create value. Similarly, most tech transfer offices, for the record, are assessing invention primarily as potential licenses, not for spin-outs, not for the many other kind of various ways of commercializing that. And so there's an argument to be made that in the first place, it's an adverse selection bias in there. Finally, I'm just going to talk once more about Imperial, because that's where I was working before I started Deep Science Ventures. It's an organization which has 500 million in research funding each year. They have 10,000 scientists there. Each of those scientists is roughly publishing a paper a year. From those 1,000 papers, 10,000 papers, you're getting roughly 1,000 invention disclosures. So of those 10,000 pieces of knowledge, they're saying, roughly 1 in 10 of them is an invention of some kind. And then those 1,000 inventions go to an office of 50 people, who then have to filter through those. And from those 50 people, you generate roughly 5 companies per year at Imperial, recognized one of the most innovative universities in the world. And then people come to the university and they ask, where is the bottleneck in this process, as if it's a difficult question to answer. So you've got on these two numbers here, you've got 1 in 10, like 10% of the value created is coming from the invention itself, and then you've got 1 in 10 of your papers published is going to be disclosed as an invention. And so probably, if you're looking at the inventions from university, you're missing 99% of the value creation from that institution. And I think probably it's an impossible problem, by the way. I think filtering such a large amount of information based on just the technology is unconstrained in a way that's probably unsolvable, even if you had 1,000 people per university. And so I'm going to suggest a decentralized strategy for filtering knowledge. And I don't mean Web3 for the people who are following the DeFi movement. What I mean is talent. So what I'm going to talk about is that embedding a different kind of scientist into labs and into academia, and incentivizing thinking from social outcomes, and working backwards rather than forwards from technology. So working backwards from the social outcome you want to achieve rather than forwards exclusively from the technology, we can make this easier. So then the second part of the talk is going to be about talent. So at the same time as we've got this vast, underexplored knowledge space in terms of its applications, the UK alone, and I'm apologizing, I have to apologize for talking repeatedly about the UK, but that's where I'm from and that's what I know. We're going to have a shortfall apparently of 150,000 researchers by 2030 if we continue to train researchers at the rate at which we train them. And at the same time, the Royal Society published an influential report, which is now slightly out of date, but it estimates that roughly 80% of those trained in postgraduate science are going to leave advanced research at some point as well. So if you want to get 150,000 who are going to stay in science by 2030, you're going to have to train 750,000. And those are just the researchers who are going to expand what we know. They're not going to be the ones who are digesting it into inventions and translating it. So then this is kind of one part of the research problem that we have. And to make matters worse, I think something that's slightly less often talked about is how biased this funnel is. So now using US statistics, so I don't have good UK statistics, from undergraduate to PhD, black STEM representation falls roughly 54%, whilst white STEM representation falls roughly 1%. And so you see a huge racial bias as you move from undergraduate to PhD to postgraduate advanced training in science. And this gets to the point where most supervisors in science in the English-speaking world are white. In the UK, we have one black chemistry professor in the entire country. For some reason, this is kind of, I don't know why it's not really spoken about so much, but it's kind of overwhelming. It's not that we don't have so many people from ethnic minorities starting science degrees. It's that they don't finish. They're weeded out by institutional racism. It's not a very friendly thing to talk about. But we do have a challenge in STEM around diversity and about how we engineer diverse leadership in the STEM community. So to summarize the argument so far, we've got this huge amount of information and we've got this flawed, like single-dimensional talent pipeline to address it. And then the third aspect is obviously the sense of urgency that we have. So we kind of need this thing to work super, super well. We've got myriad problems. I'm not going to go into it in detail, but obviously you've got climate, you've got aging, you've got disease, etc. So there's quite strong motivation to get this to work. And so the big solution that I wanted to big idea that I wanted to kind of present today was this idea of a kind of intentionally overlaying an R&D ecosystem that is outcome-centric. So imagine you could get and a research infrastructure that was as big and as well funded as discovery science, but pointing the other way around from outcome backwards. And you could integrate it with our existing scientific research infrastructure. And imagine that overlaid ecosystem was staffed entirely with people who are thinking exclusively about how can we solve these problems. And imagine we weighted it equivalently in terms of the value of it. And we called it science still. And we called the people who did it scientists, because you have to understand science and be able to combine 10% with 90% to get 100%. There's lots of great examples of outcome-centric R&D. Amir gave us a few. I'm going to give you just 3 from my own portfolio. So as I said at the very beginning, which most of you may have already forgotten because I've been rambling for like 5 minutes now, is we create new companies from scratch, and we do this from an outcome backwards. And so one of the broad things we work on is climate. One of the sub-problems inside of climate that we're focused on is liquid fuels and replacing petrochemically derived liquid fuels with alternatives. And we broke this down into 3 sub-problems. On the one hand, for a kind of non-petrochemically derived liquid hydrocarbon, you need green carbon dioxide. You need green hydrogen on the other hand, and then thirdly, you need some way of combining them to make your liquid hydrocarbon, your fuel, your gasoline, and all of the kind of basics of the chemicals industry. And so what we did is we decentralized responsibility to this to 3 specialized teams, each led by someone I would consider an outcome-centric scientist, so someone who has been trained to think in this combinatorial, outcome-centric way. Totally agnostic as to the technology that they're going to end up using, but dogmatically and overall focused on solving that particular problem. And we gave them a vast amount of time to do this. We gave them a year to think about what the kind of sub-outcomes they need to solve in order to get that done are. We then ultimately, in the space of that 12 months, produced 3 companies. One of them is a company called Mission Zero, and it's just really convenient that your talk was just before mine. So Mission Zero was in a team with a company called 4401, and they won the Carbon X Prize. And so I am going to mention Elon Musk in my talk, because Elon Musk gave this company $1 million, which is like one of the proudest moments of my life. And Bill Gates also gave this company a load of money as well, in order to do carbon removal using electrochemistry. The second company we produced is a green hydrogen company called Supercritical, and they produce high-pressure green hydrogen designed to be inputted into the e-fuels industry. And the third is a company called Dunia, and Dunia is relevant because we incorporated it here in Berlin. So whilst we're a London-based firm, we put the companies wherever they need to be. And if you want to hear from an outsider what the experience of starting and fundraising for a Berlin-based company is, then please ask me a question about that, and I will complain for my full 7-minute quota.
Which is almost over.
Okay. Okay, so like in sum, I guess, we work actively parallel 15 areas simultaneously where each of these kinds of things is happening. So 2 to 3 companies from each of those areas. In order to do that, we've had to build a load of infrastructure. So search engines for talent, ways of mapping the problem space, a little bit like the kind of tech road mapping or tech tree type structure that Amir flashed up on the screen. But systems like that aren't going to solve the problem alone. We still have to recruit people with PhDs who understand combinatorial innovation. And so one of the things that we're launching at the moment, which I have to mention in the last few minutes of my talk, is a brand new PhD program. So instead of training existing people, the set of people who currently opt in to do PhDs, or trying to recruit the people who finish their PhDs, our idea was, how can we do more than just talk about this parallel infrastructure and create an entire brand new PhD program? So we've designed and last month unveiled a global decentralized PhD program. It's going to be run by a meta university, and the PhDs will each sit in existing research labs. So instead of trying to recreate the academic system from scratch, the idea is to overlay it with existing academic systems. And each of those PhDs will be trained specifically as combinatorial innovators. So instead of becoming an expert in one specific scientific discipline, they'll become an expert in one specific social outcome. And they'll learn all of the possible ways of trying to get to that problem, and they'll run a series of targeted experiments to understand whether or not scientific hypotheses related to solving that problem can be proven or disproven. And this is one of those things that, we do venture creation. This is sometimes like a lone pursuit, but a PhD program like this has to be super collaborative. And so the kind of closing message is, if you'd like to collaborate on creating a program which trains 1,000 or more combinatorial innovators who work in some of the most entrepreneurial and inventive labs in the world, and make sure that we see some of the rest of that 99% of science, and I'd love to talk to you after. Thank you.
Wow. You must be psyched after that. I'm pretty psyched about that. Questions for Dominic, please. Don't make me ask a question.
I have a question.
What?
Or you go.
I can't see. I'm a bit blinded. Go at the back. Yeah, yes, please.
Okay, perfect.
Yes, please.
I have a question, and I'm really thrilled about the input, because you'll see I'll reference it in just a second a little bit. So if you're saying, let's imagine a world where we still call these people scientists, but we kind of change the approach. How would, for example, because that was one of my questions, for example, in my talk, how would a scientific paper look like?
So in this case, the paper would be, you could imagine each chapter thinking about a different approach to solving that problem, and what the kind of roadmaps and bottlenecks in that would be, and what remains as an unknown question in order to resolve it. So it remains a scientific analysis of a problem, but the directionality is simply from whether or not that a particular approach on that chapter is going to solve that problem.
Thank you. You'll have to stop you there. Are you Nicole? You might want to start coming up to the stage. Right, one quick question, 30 seconds. I think there was a hand over here. You put your hand up. Who? What? You've spoken so much. Give him 10 seconds and 5 seconds to answer.
How do you credentialise the PhD? How do you get the academics like us to buy in?
Hey, Lee, would you like to potentially host? That's fantastic.
Oh, right, you two know each other. Get off the stage. Dominic Falcao, thank you very much. Okay.